All right, so this is our last section in this chapter trig class. We're going to be looking at using the definitions of the trigonometric functions. So we're going to be looking at some identities in this section. These are first of many identities that we'll be looking at, and we'll keep on using these same identities throughout all of trigonometry too. So learn them, know them, how to use them. And I will probably let you have an identity card sheet or something like that on tests and stuff. So, and just ask me about that later when we come to the test, like we're about to. But let's go on. Here's our first identities. We kind of noticed this already in the last section. We have something called reciprocal identities. Sine and cosecant are reciprocals of each other, so sine of theta is equal to 1 over cosecant of theta. And then same thing goes here. Cosecant of theta is equal to 1 over sine theta. And cosine is 1 over cosecant. Cosecant is 1 over cosine. Tangent theta is 1 over cotangent theta, and cotangent theta is 1 over tangent of theta. So we kind of already noticed this identity in the last section when we were dealing with numbers. But let's move on to our first example. Okay, so here is our first example that we'll be looking at. Getting my pen tool ready. All right. We are going to be looking at find each function value that we're asked for. So in part A, we are asked to find tangent of theta, given that cotangent of theta is equal to 4. Well, if we look at this as cotangent of theta is equal to 4 over 1, then tangent of theta, since they are reciprocal functions, is equal to 1 over 4. And then similarly, we have secant of theta is what we're asked to find if we are given that cosine of theta is equal to negative 2 over square root of 20. Well, again, that's not that hard to find. Just flip this around and we've got our answer. So secant of theta is equal to negative square root of 20 over 2. And we are done. That square root of 20 can actually be simplified and everything, but we're not going to worry about it at the moment here. All right, signs of function values. So if you haven't figured this out already, we have quadrant numbers here, 1, 2, 3, 4. Remember, go in a counterclockwise motion to number all of these quadrants. All function values of our trig functions are going to be positive in quadrant 1. Sine and cosecant are going to be positive in quadrant 2. The rest of them are going to be negative. Similarly, we have quadrant 3, tangent and cotangent are positive, but the rest, sine, cosine, cosecant, secant, are all going to be negative. And then in quadrant 4, the only two that are positive are cosine and secant. The rest are negative. Here's another slide that's saying the same exact thing, but here is just kind of laid out for you differently. In quadrant 1, see how we have every sign of each of these functions, 6 functions, are going to be positive. In quadrant 2, sine's positive, cosine, tangent, cotangent, secant are all negative, and then finally cosecant is positive. So remember, all of the reciprocals of the functions like sine and cosecant, they're going to have the same function value. And And then tangent and cotangent, like this in quadrant 3. They're both positive. Sine and secant, cosine and secant. They're both positive in quadrant 4. The rest are negative. So pretty much said the same thing as I did in the previous slide here, just a little bit different in a table form. All right, so next example. Okay, so example 2, what we have here is we're going to determine the sine of the trigonometric functions of an angle in standard position with the given measures. So part A, this angle right here, I'm going to kind of just draw this out for you. This lies in quadrant 1, so it looks something like this right here. There's the angle measurement right there, 54 degrees. Okay, so angle 54, that's in the first quadrant. And as this thing stated before, all functions are positive in the first quadrant. So that's the answer to this right here. All are positive all 6 trig functions are positive for this angle measurement right here. Part B, this angle measurement right here, well, to kind of draw that out for you, let's look at that. It's going to be something close to this line right here. That is our angle measurement. About 260 degrees is that. Well, that is in the third quadrant. So go back to what we said about things that are in the third quadrant. All sine functions in the third quadrant are negative except for tangent and cotangent. So write that as your answer to part B here. Tangent and cotangent are positive function values, and then sine, cosine, cosecant, secant are negative. All right, and then this part C, what that is going to look like is this here, because we're going in a negative direction. Again, well, we are in the fourth quadrant. So go back to your list of things here and look at the fourth quadrant. So cosine and secant are positive. Sine, tangent, cotangent, cosecant are all negative function values. And that's how you answer part C. Okay, so that's what I'm asking you to do on these, is just determine the sides of each of these 6 trigonometric functions by figuring out what quadrant these angles are in. All right, here in example 3, it's kind of like we're going to be doing this in reverse. So we're going to figure out what quadrants these examples are possible with these conditions that we are given. So identify the quadrant or possible quadrants, because it's possibly might be 2 quadrants of an angle theta that satisfies these conditions. So part A says tangent of theta is greater than 0, meaning tangent of theta, this is positive, or tangent is positive, and cosecant is less than 0, meaning cosecant is negative. So going back to this right here, tangent is positive in the first quadrant and in the third quadrant, but there's no negative signs in the first quadrant, so cosecant is negative in the third quadrant. So the quadrant we are looking for part A here is going to be quadrant 3. So just name Q3. Okay, that's how we do these problems. Let's do the next one together. We have sine of theta is positive and cosecant of theta is positive. Well, we look back here. All signs are positive in this first quadrant, so this is a positive possible one. And then the other one, where sine and cosecant are positive, are in quadrant 2. So this one actually has two answers to it, quadrant 1 and quadrant 2. And that's our answer for that one. Now, on this right here, understanding the ranges of trigonometric functions, this is going to apply to this next example that we're about to do. And to apply that, what I'm going to do is show you that where we come up with the range for each of these trig functions. So sine and cosine, if we were to look at it graphically, sine and cosine both have a similar pattern. It's an oscillating pattern that goes like that. And it oscillates between 1 and -1. So that's why the range for sine and cosine is -1 to 1. And then tangent and cotangent, they also have a similar pattern for its graph. I'm going to graph just one of those. It has asymptotes on it though. Oops. They have a graph that looks like this right here that repeats over and over, kind of like this oscillating pattern for sine and cosine. But it repeats this pattern here over and over. And the range on this one, well, there are no bounds. So that's why it's -infinity to infinity. And then secant and cosecant, the graph of that looks similar to this. It's going to have a curved portion here, and then down here, again up here, and it's going to keep that pattern too. But the reason that we have this union symbol right here is because, yes, it goes from -infinity to +infinity, but it skips the portion between 1 and -1. You will never have values that are between -1 and 1 for secant and cosecant. Okay, so let's look at this next problem. So we are deciding whether each statement is possible or impossible. And here we are asked for cotangent of theta, can it equal negative 0.9999? Well, if we were to look back at our range here, tangent and cotangent, they can equal any real number. So part A here, it is possible. So write that, possible. Okay. And then cosine of theta is equal to negative 1.7. Well, go back to this right here. And sine and cosine both are between -1 and 1. So nothing less than -1 and nothing greater than 1 can sine or cosine equal. So for this one, a negative 1.7, that's less than -1. So that is not possible. Okay. And then cosecant of theta equals 0. Well, again, let's go back here. Well, 0 is between -1 and 1. And it will never be, there will never be a value between -1 and 1. So for the solution to this right here, again, it's not possible. Okay, so that's how we do those problems. Okay, in this example, we are asked to, it says angle theta lies in quadrant 3 and tangent of theta is equal to 8/5. Find the values of the other 5 trigonometric functions. Well, we should know tangent of theta is equal to y/x. So we have our y and we have our x, but we also have this statement right here that angle theta lies in quadrant 3, meaning actually both of these, y and x, are going to be negative because everything in quadrant 3 is negative. All your x and y values are anyway. So y is -8, x is -5, and if we plug it into that formula, the square root of x squared plus y squared, that is what r is going to equal to, and r is equal to, let's see, the square root of 89. There we go. So having these 3 things figured out now, that's what you need to do from the beginning. Just figure out what is y, x, and r. We can figure out what sine, cosine, already got tangent, um, cotangent, and secant and cosecant all are from this right here. Really, right off the bat, we should know what cotangent is equal to. Cotangent is going to equal the 5/8, just the reciprocal. Let's go ahead and write that. Now, cosine, or let's do sine. Now that we figured out what r is equal to, we can figure out that it is equal to y/r. So -8 over square root of 89. All right. Remember, rationalize that denominator. So -8 square root of 89 over 89. And then the cosecant, let's go ahead and do cosecant since we figured out sine. Cosecant is the reciprocal of sine. So negative square root of 89 over 8. And now let's do cosine. Cosine is your, let's see, x over r. So -5 over square root of 89, or -5. Yeah, let's go ahead and do square root of 89. Or rationalized, it would be negative square root of 5. Oh, sorry, -5 square root of 89 over 89. And now the secant of theta. Secant of theta is equal to negative square root 89 over 5. And we're done with that. So there's the rest of the 5 trigonometric functions given, 1, and what quadrant it is in. So these next 2 slides, we're going to see some more identities. These right here are called the Pythagorean identities. And here we get sine squared theta plus cosine squared theta is equal to 1. What I've told previous classes, if this right here does not make sense to you, another way of writing sine squared theta and cosine squared theta, so just say if I have sine squared theta, that is the same thing as saying sine theta all squared. Okay, so this is an identity that we are going to be using in one of our next examples. And then from the sine squared theta plus cosine squared theta equals 1, we can use other trig functions and get these other two identities here that are also known as Pythagorean identities. Now, quotient identities are these right here. Tangent of theta is equal to sine theta over cosine theta, and cotangent theta is equal to cosine theta over sine theta. So these are very useful also in figuring out values of trig functions. Okay, so in this next example, we are asked to find cosine theta and tangent theta given that sine theta is equal to the negative square root of 2 over 3 and cosine theta is greater than 0, which means cosine theta, that function value is positive. So knowing that sine of theta, that value is negative, and cosine is positive, if we go back to this right here, sine is negative, but cosine is positive, that means we are in this fourth quadrant right here. Okay, so remember that we are in the fourth quadrant. I'm going to write that down. We are in quadrant 4. Yeah. And that is going to help us in figuring out the rest of our functions, values, possibly. Okay, so what we're going to do here in this one to help us figure out what cosine of theta and tangent of theta are equal to, we're going to be using our trig identities that we just looked at. So one of the Pythagorean identities stated this right here, that it's going to disappear on me. Yep. Okay, that sine squared theta is plus, that's a plus sign there, cosine squared theta is equal to 1. We have sine of theta. We can plug that into our function here and then solve for cosine. That's what we're going to do. Remember how I said that sine squared theta is the same thing as sine theta squared. So that's what we're going to treat it as. We're going to square this, add it to cosine, and solve for cosine. Square theta. Solve for that one first. And what we get is, let's see, we end up getting cosine squared theta is equal to, let's see, 7 over 9. Now take the square root of both sides to get rid of that square. And remember, we have a plus or a minus here. That's where this comes in handy, that we know cosine is positive. So the value of cosine here is also going to be positive. And we're not going to worry about the minus part of it. So we get square root of 7 over 3, actually. There's 7 over 3. Now, we found what cosine is equal to. Let's find what tangent is equal to. And I think the easiest way to go about finding tangent whenever you have the solutions for sine and cosine, see we have sine is equal to negative square root of 2 over 3, and cosine is equal to square root of 7 over 3. Well, since we know both sine and cosine, we can use this quotient identity right here to figure out what tangent of theta is equal to. Let's do that. Tangent of theta is equal to sine theta over cosine theta, so negative square root of 2 over 3 over square root of 7 over 3. Well, our denominators are the same and they end up canceling out, so we get the tangent of theta is equal to the square root of, let's see, 2 over the square root of 7. And it's the negative of that. Okay. And again, rationalize this thing. Multiply both numerator and denominator by the square root of 7. So we get negative square root of 14 over 7. And we're done. We found the tangent and the cosine given some information. All right, this is our last example we're going to be looking at, and it's very similar to the previous one. We're finding what sine of theta and cosine theta are equal to, given that cotangent of theta, and this is supposed to say is equal to negative 7 over 24, and theta is in the second quadrant. So if we go back to what's positive, what's negative, in whatever quadrant we're in, we should know that, I'm going to put this up here, that sine is positive in the second quadrant and cosine is negative. So let's remember that. And then how we're going to figure out what is sine and cosine is by using our identities here. I'm going to go back to this Pythagorean identity right here. We are given cotangent. All right, we are given cotangent. Let's see. Yeah, we are given cotangent. So we can actually use this Pythagorean identity right here and solve for cosecant. And then once we figure out what cosecant is, from cosecant, we can figure out what sine is. Because cosecant is 1 over sine. Hopefully y'all followed that logic there of what I'm about to do, because I'm going to say 1 plus cotangent squared theta is equal to cosecant. So let's write that down. 1 plus not cotangent, it's cotangent squared theta is equal to cosecant squared theta. Plug in cotangent into your cotangent squared. So 1 plus 7 over 24 squared. That's negative. Doesn't really matter when you square it though. And that's equal to cosecant. Cosecant. There we go. Now let's figure out what this side of our equation is equal to. Okay, so we actually get some pretty big numbers here. I had to stop and get me a calculator. This side of the equation, right here is equal to 625 over 576. These are actually, you're able to take the square root of these two numbers evenly. So I'm going to go ahead and say cosecant of theta is the square root of that. And remember, cosecant's positive because sine is positive. Cosecant here is going to equal, let's see, 25 over 24. So if we have cosecant of theta is equal to 25 over 24, then we should know, remember, reverse that, and that is what sine is equal to. Sine of theta is equal to 24 over 25. There we go. There's one of our answers. Now, similar to how we found what tangent was equal to in this problem, we can find what our cosine is equal to. So we have cotangent, we have what sine is equal to. Let's figure out what cosine is equal to by saying, multiply. Say cosine of theta is equal to cotangent times sine theta. So let's do that. We have, whoops, get my pen. Cotangent of theta is equal to cosine theta over sine theta. So in the previous slide, we found what sine is equal to. It's 24 over 25. So we need to find what cosine is equal to. Cosine, in this case, is going to equal, well, if I multiply sine on both sides of my equation, I get cosine is equal to cotangent theta times sine theta. We have both of those. Cotangent, if you remember, oops, that's not what I wanted. All right, let's get my pen tool back. All right, so cosine of theta is equal to, well, cotangent was the negative, what was it, 7 over 24. Yeah. And sine was 24 over 25. Well, the 24's cancel, and so we get negative 7 over 25 is equal to our cosine of theta. And we are done. So that's how we kind of manipulate to find function values using our trig identities. And we're going to be doing that a lot in some more chapters, manipulating these identities that we are given throughout these chapters to find values of different things and other stuff. But anyway, we are actually done with this whole section and our whole chapter now. So I will see you all in class. Goodbye, everybody.